Welcome to setting up Oracle VirtualBox to run Solaris 11 Express to go through the exercise we're going to go through for the ZFS file system using 6 USB sticks on a Windows machine. What we first have to do is set up VirtualBox. And this screen is a VirtualBox manager screen. I've set up 3 virtual machines. The one that's going to do ZFS is the machine called ZPool Demo. And ZPool Demo is set up with 3.5 gig of memory, 2 processors. So it's a pretty substantial machine. Also, the USB devices. I have 6 USB devices. I added them using the plus sign. Over here are all the USB devices that are connected to my computer. And these 6 jet flash, I used the plus sign and I brought them over here. And they'll be transferred to the machine. Let's bring the machine up. Now, before we do that, here is the USB hub. It's a 7-port CyberPower USB hub with 6 4-gigabyte jet flash transcend USB sticks. And these 6 USB sticks, 1, 2, 3, 4, 5, 6, and that's what their names are. 1, 2, 3, 4, 5, 6. Very creative. They will be the 6 disk drives that we'll use doing this ZFS demo. Well, let's bring this machine up. I hit start. I'm going to lower this. Click through a couple of annoying pop-ups. Okay, I'm going to do a pause while Solaris boots. And notice that now we have the log on screen. I'll adjust the size of this window so that both of these fit the same. Going to log in. And notice as we log in, you'll notice some LED activity. I chose these particular USB sticks because they had LEDs to indicate that there's some actual activity with it. It's not unique. But notice number 2 here is activating. The Solaris operating system is going to go out and query each one of these USB drives and then figure out what it is, and then it's going to mount it. So the first drive that we'll see mounted here on the left will be 2. Now 2 is mounted, 1 will mount next. So I'm going to pause this and then we're going to see all 6 drives mounted. Now the operating system has gone through all 6 drives. We'll grab a terminal and we'll use RM, which is rewritable, format. We'll use that command. You can use the RM format or RM format minus L. It'll give you the same output. And you see that we have 7 devices. 6 of these devices are Jet Flash Transcend 4 GB, and they are C0, T0, D0, P0, C1, C2, C3, C4, and C5. The last device is C7, and it's the DVD or CD-ROM. It's a DVD reader or CD reader. This concludes this presentation. What we've covered is how do we get these 6 USB sticks connected to a VirtualBox operating system. We said that we did it through the VirtualBox Manager USB section, and here are the 6 USB sticks. They're automatically transferred over to this operating system. Thank you for watching. Have a great day. Hello, this is a hands-on introduction to ZFS pools. This is part 1. We're going to create a Z pool. We're going to show you how to get the status of the Z pool. We're going to add drives. We're going to export a Z pool, and then we're going to import a Z pool. Now, the things that we need to do in order to start is to become the super user. So this screen is a VirtualBox Solaris 11 Express screen. It's a virtual machine. We click the terminal, do an SU, type in the super user's password, and we are the super user. Now, the next thing that we need to do is stop the volume manager. And the way we do that is we come over here and we do SVCS for services and all, and then pipe it to Gret vol. And you'll see here that the vol manager, or removable vol manager, is disabled. If we needed to disable this vol manager, we would type in SVC80M disable, and it's just going to disable the disabled volume manager. Now, the next thing we're going to do is check and see what drives are connected. And you can see over here in the picture, we have 6 USB drives. And they're numbered 1, 2, 3, 4, 5, 6. And they are, in fact, connected to the machine, and we'll show that by typing in RM format. And it shows us that we have a Jet Flash 4 GB USB device, and it's called C0, and I'd shown this before: C0, C1, C2, etc. So the next thing that we want to do is to see, are there any existing Z pools? And there is called RPool. It's 30 gigabytes, which is much larger than what we have. So we're going to create what's called a striped pool, where we're going to write across one or more of these 6 drives. And we do that by the command called cpool create, And we're going to use C0, T0, D0, P0, and C1, T0, D0, P0. And keep an eye on these two devices. And you'll see the activity of C0 and C1. I'm sorry, I put them in a different order. And that is our pool. And now to see what, if anything, or what the status of the pool is, we come over here and we do zpool status of Fred Stripe. And it tells us that we have two devices that we put in, C0 and C1, and they're online. So now we'll put some data on that stripe by CDing there. And then what we'll do is we'll use tar and we'll come over here and create a tar file that should be a sizable, like about maybe a gigabyte. And you notice that the two devices, C0 and C1, now are getting data. We can do put this in the background. All right, and now what we can do is we can expand this pool. And what we will do is we'll do a thing called add. And we'll add, let's say, 4 more of these things. So we'll do C2, T0, D0, P0, C3, T0, T0, P0, C4, T0, D0, P0, and C5, T0, D0, P0. And notice that we're still adding data and we're still adding to the pool. And now you notice that now there's data, now that we've added it, the data is now being distributed among all the drives in our pool. We finished writing data to the stripe. Do an ls. And we have a file somewhere around a gig. It's called test.tar. So that's the file that we created when we did the tar. And the data is in fact distributed among these 6 drives. Some drives will have more data than the other. Now, what we can do here is export the pool. And if you want to remove these drives and move them to another machine, normally customers don't do that. Basically, customers don't physically move the disks around. They move them around on some sort of a SAN. And this is represented by or enabled by us doing a zpool export. So we can do a zpool export here. And the reason why we have a device busy is because we're in the directory We do a CD to our home directory. And I'm lazy, so because we have the bash, we can do this. Escape K, K, K. And we can export the pool. Notice the activity on the LEDs. The pool now can be removed. If we were going to do anything with this, like take the drives out, and we wanted to use it, we could in fact import the pool. So if we go down to, or we go to a thing called Places and Computer, there are some things here, but there is no Fred stripe here. There is one here, but it's not mounted. So if we're going to take a look at that, we'd have to mount this. And the way we would do that is we would do a zpool import. Down here. Now, also you see activity on the drives, and now we've actually put the drives back in. So if you're going to shut down a machine, especially if you're going to use this setup here to bring down the machine, you should in fact export that file system before you shut down the machine. All right, well, here is the end of the first section. The second section. All right, this is the second section. This is called ZFS mirrors, managing disk failures, and spare disks. So what we're going to do is we're going to become root, stop the vol management, which we've done before, run devfs adm-c, we've done that before as well. What we're going to do is create a mirror from 2 USB drives at a time. We're going to stress that mirror, and then while we're stressing it, we're going to add another mirror to it, and we're going to add 2 spares, and we're going to simulate a bad drive by pulling one stick, and then we're going to replace the drives by using zpool replace. Now we've already gone through the setting ourselves up as root and clearing out the device tree. We know that the devices are C0 through C5, T0, D0, B0. So what we're going to do now is we're going to create a mirror, and we're going to call that mirror mpool, and we're going to add drive C0, T0, D0, P0, and C1, T0, D0, P0. So notice that these 2 drives are now part of the mirror. So we get the status, and in mirror 0, we have 2 drives, C0 and C1. Again, this particular zpool is going to be mounted on /mpool. So we'll cd to /mpool, and we'll do our famous tar. And we'll stress the mirror by adding these files to the mirror. And also, in the meanwhile, what we're going to do is we're going to add 2 more drives to that particular pool. And we'll add C2 and C3. See that we have a second mirror. Then these 4 panes of the mirror are in fact part of mirror 0 and mirror 1. So C0 is mirrored with C1 and C2 is mirrored with C3. Next, what we're going to do is we're going to add some spares. And we do that by making C4 and C5 as spares with that pole. Notice the activity of these two as being spares. And you can see that the spares are now added and they're available. So let's pull one of the sticks. We'll do a status. Notice that this spare is having a lot of activity. It's in the process, I believe, of resilvering. And you can see that the spare, so mirror 1, which is C4, is taking this spare, which is currently in use. And notice that C3 was removed, and it is in fact resilvering that drive. I'm going to put the drive I pulled out, put it back in. Nothing's going to happen for a while. The system sees the drive. That was a message saying it couldn't mount the drive. When we see the status, we see that C4 is still in use. C3 is now online. C4 is also online as part of mirror 1. And you'll notice here there's an active activity going on where C3 is resilvering because Z-Pool, or the operating system, realizes that we put a drive back in there. And now Z4 is available, and Z3 has been resilvered, and we are now continuing to download the data to that mirror. And here you can see that the user tar file is increasing in size. So this is all done automatically. This concludes this section. Hello and welcome to the last section of our Z-Pool demo. And this section is called RAID 2Z and resilvering and scrubbing. A RAID Z2 file system is a file system that has 2 pieces of parity written on the drive as opposed to just one in a typical RAID 5. This is not really RAID 5, it's a different algorithm, meaning the way they write the data to disks. In our case, we're going to change the disks, and we're going to do that by only having 4 this time. What we're going to do here is create the Z pool. And we're going to create it with 4 drives. We're going to create it with C0, T0, D0, P0, and C1, and C2, and C3. And you'll notice over here that these 4 drives, these 4 corner drives are going to be the active drives. So we hit create. And we've created our file system. And we'll check out the status, and you can see down here in the bottom that the status is a Z2 pool with 4 drives. Now, what we're going to do next is we're going to CD to that directory. Remember, it's at the slash level. Named after the pool. And we're going to create a large tar file like we did before. And put that into the background. And as that's happening, we'll see that the data is writing to the disks, and what I will do is I will pull a drive. And the data is going and going and going and going, and I will pull a drive, this drive. And we'll get a status. And we see that the status is degraded and that C3, T0, D0 has been removed. Now, we've only used 4 drives, so we have C4 and C5. Now, I can use, as the suggestion here is, here we see at the top where it says the Z2 pool is degraded, and then it says one or more devices has been removed by the administrator. There are replicas so the pool can continue, and we can either replace the device and do a Z-pool online, or we can actually replace the device with a Z-pool replace. So let's do a Z-pool replace, and we're going to replace C3, T0, D0, P0 with C5, T0, D0, P0. Now the tar is completed. And notice that all the drives are in fact running, and that's in order to give the machine enough data so that it can reconfigure the device with the actual data that should be on it. We'll pop another window here. And we'll do a Z-pool status. And you can see right now that it is degraded, but C5 is now being resilvered. So what we've done so far is we've created a pool. It has multi-parity bits, and that we can pull a drive. We could literally pull two, and that we could replace a drive, and it will be resilvered by the Z-Pool logic and recreate that data on another drive. So I'm going to stop the machine here and continue on when this is finished resilver. Okay, so the machine is completely resilvered the drive, so we'll check the status. And everything is fine. Notice that C3 no longer is in the picture and C5 is there. Now, what happens if we put C3 back in? Let's try. And it's going to be recognized as a regular drive. It says, I'm sorry, I can't mount it to Z2Pool because it recognized that it was in Z2Pool before. And it's going to start looking and doing things. So let's see the status. Still as C5. So it's not like we had a hot spare. This is in fact completely moved. And we can also go back and do a replace if we choose to do a replace. The last thing that we need to check is, of course, we need to check to see, okay, so we've gone through and created a Z2Pool. And now the last thing that we need to do, or we're going to talk about, is scrubbing. And in this case, we're using very low-cost USB memory sticks, and they're not really made to be in a professional data center. They'll degrade over time, but these were used just for an easy example and a relatively low cost compared to disk drives. But scrubbing is something that's been around for a while. The ZFS provides that mechanism so that we can perform routine checking for the integrity of the file system. It's typically used in memory and other systems as a method of detecting and preventing errors before they result in catastrophic hardware or software failures. So performing routine scrubbing guarantees continuous I/O to all the disks on the system. It has a side effect of preventing power management from placing these disks in a low power mode, spinning down typically. And then if the system's generally performing I/O, they won't go into this power management system where the disks are not spinning at all. So if power consumption isn't a concern, or if the system is generally performing I/O all the time, then this issue can be ignored. When a device is replaced, resilvering is initiated to move the data to a new device. However, when we scrub, we'll check this integrity to make sure that the data is really there. So we go about doing a scrub by typing in Z-Pool scrub in the name of our pool, which is the Z2Pool. And we'll put this into the background. And you can see that the drives are going away, checking the scrub, and then we can do a status. If we weren't in caps lock. And you can see here that a scrub is in progress. And this tells how long it takes to go, how much was repaired, how much was done at the time. Notice the scrub is a fairly quick action, but we have a fairly small file system and not much data on it. We only have a tar from a small directory. So this concludes the ZFS video demo. Thank you for watching. Have a great day.